Okay, so today we're going to get into something called the rate law, and we're going to learn how to determine it. So when we look at a reaction and try and figure out what kind of effects the reactants have on a reaction, we come up with something called the rate law. And the rate law is an equation that looks like this. Rate equals K concentration of A raised to some power, concentration of B raised to some power. And so it would look something like this, where these are your reactants. The powers are what we call the orders with respect to those reactants. So these will be, they can be any number. They can even be negative, they can be decimals, but for our purposes, for this class, they're going to be 0, 1, or 2. Okay? A zero order reactant, if I raise A to the 0th power, anything to the 0th power is equal to 1. So whatever I do to this concentration is not going to have any effect. So a zero order reactant has no effect on the rate. So I could double it, I could triple it, I could do whatever I want to it. It's going to have no effect on the rate if it's a zero order reactant. A first order reactant, so if X was 1 or if Y was 1, then whatever I do to this, again, it's going to stay the same. So whatever I do to concentration, concentration change will be proportional to rate change. So if I double the concentration of A, the rate will double. If I double the concentration of B, the rate will double. If I triple it, the rate will triple, and so on, if those are first order reactants. Now, if it's a second order, so if this X or this Y is 2, that means that I'm going to square whatever change. So the concentration change will be squared, and therefore if I double A and then raise it to the second power, that's like quadrupling the rate. Okay, again, if it's second order. So K, so these exponents right here are the orders. K is the rate constant. It's little k, and it's a constant that will not change until or unless the temperature changes. So at constant temperature, the rate constant K is constant for any reaction, and so that really isn't going to affect anything when I change my concentrations, because theoretically this should be the same. Now if I want to know the overall order for a reaction is the sum of individual orders. So if I have two reactants A and B, and let's say X was 1 and Y was 2, the overall order would be 3, because it'd be 1 plus 2. Okay. Now, given data like this, how do I figure out what the rate law is? Okay, so here we have a reaction, and here we have several experiments, and the rate law can only be determined through experimentation. Okay, so we have to do several experiments, change things, and keep things the same that we want to keep the same and change. So first of all, my rate law is going to be rate equals K, and then I'm going to have ClO2 raised to some power, I don't know what that power is yet, and then OH minus raised to some power, okay? Again, only the reactants appear in your rate law, because that's what's going to affect the rate of the reaction is the reactants. So here's what you do. So if I want to know the order with respect to a certain reactant, I need to change that reactant but keep the other reactant constant. Because if I keep the other reactant constant, then the effect on the rate is only going to be what I did to the reactant that wasn't constant. So for instance, in experiments 1 and 2, I keep ClO2 constant. OH minus, we can use the arrow method. So this, I'm doubling this. I'm multiplying that by 2, right? So however it affected the rate, this didn't have any effect on it. Whatever I did here must have changed the rate. So I double the concentration of OH, and if I look here, this is also doubled. It's going from 1.3 times 10 to the minus third to 2.6 times 10 to the minus third. Okay, so if I double the concentration and the rate doubles, that's a direct relationship. They're directly proportional. That's going to be a first order reactant. So then what I would put here is a 1 by the OH. It's first order. Because what I did to the concentration, that the same thing happened to the rate. Okay? So it's first order. You wouldn't have to put a 1. Again, it's understood if it's just by itself. It's to the first power. Okay? So now, this next one, how do I figure out the order with respect to ClO2? Okay, well, I'm going to look where OH is the same. So in 1 and 3, OH stays the same, right? So I'm going to look at what happens, or what did I do to my ClO2. So between here and here, this went up by 3. I multiplied that by 3, right? 0.015 to 0.045. Multiplied by 3. Here to here, if you take this number and divide it by that number, because it's kind of weird because you have the exponents, but this is multiplied by a factor of 9. So I tripled the concentration here, and my rate went up by a factor of 9. So you can think about it like this, is I raised it by 3, and then I raised it by some factor or some exponent, and it turned into 9. Okay? So what would x be there? Hopefully you all realize that that is 2. So this is a second order reactant. So this would be 2 there. So my rate law would be rate equals K ClO2 squared, concentration of ClO2 squared, concentration of OH minus to the first. Now, one thing that you'll most likely always be asked after you get the rate law, we determine the rate law, you will be asked what is the value of the rate constant. So how do I figure out the value of K? Well, once we have our numbers, to figure out K, we can just take one of our experiments and plug in the numbers. We have the rate, we have the concentration of ClO2, we have the concentration of OH. So plug in the numbers and then solve for K. So I'm going to do that with experiment 1. And it should be, since it's a constant, it should be the same no matter which trial we choose. And if you go through and do it, it is. So that's so it's going to look like this. So then if I plug those numbers into my calculator, 0.015 squared, so I get 5, 1, 2, I get 5.625 times 10 to the minus 6 equals 1.3 times 10 to the minus 3. Then I divide both sides by the 5.625 times 10 to the minus 6th. I get 1.3 times 10 to the minus 3rd divided by 5.625 times 10 to the minus 6th. And that gets me 231. So K equals 231. So then I can plug that back into my rate law. So like my final rate law, 231 ClO2 squared OH minus. And there's my rate law right there. And the rate constant does have units. We will get to that in a future video. Hope this helps. Let me know if you have any questions.